Introduction to deploying advanced apps. Deploying advanced decentralized applications or DApps requires careful planning and execution. Today we'll explore how to ensure your DApp functions seamlessly in real-world scenarios. We'll focus on the best practices, tools, and security measures that are essential for successful deployment. Our goal is to help you deploy your DApp smoothly, minimize risks, and ensure it performs optimally. By the end of the presentation, you will have clear understanding of the deployment process and how to navigate it effectively. Some key considerations before deployment. First, let's talk about code quality and security. Your dApp's code must be clean and secure. This means performing thorough code reviews and audits to catch vulnerabilities early. Using static analysis tools like Mithril can help identify potential issues before they become problems. Additionally, formal verification methods like those offered by Certec can mathematically prove that your critical functions are working correctly. For example, security fixes. Imagine a smart contract that allows for a reentrancy attack. This type of vulnerability lets an attacker drain funds by repeatedly calling a function before it finishes executing. By introducing a simple lock mechanism as shown in the secure contract example, you can prevent this kind of attack and protect your dApp. Next, we need to ensure your dApp is thoroughly tested. This involves unit testing, individual functions, integration testing to check how different parts of your dApp interact, and end-to-end testing to simulate real-world usage. Tools like Hardhat and Truffle makes this process easier by providing frameworks to write and execute tests. For example, testing with Hardhat. For instance, you can use Hardhat to test a complex contract by writing a test case with the Chai assertion library. You can verify that specific functions are working as intended. This type of testing is crucial for catching errors before your dApp goes live. Optimizing your smart contracts is also important. Gas optimization reduces costs and improves efficiency. For example, using mappings instead of arrays for data storage can reduce gas costs. And libraries like SafeMath ensures your mathematical operations are both safe and efficient. Preparing deployment scripts. Automated deployment scripts streamline the deployment process and reduce the risk of manual errors. Tools like Hardhat allow you to define tasks for deploying contracts and managing network interactions. For example, deploying scripts with Hardhat. Let's consider deploying two contracts, a token and a marketplace. A simple script using Hardhat can deploy these contracts to the Ethereum network and log their addresses for verification. This ensures a smooth and consistent deployment every time. Before deploying to the mainnet, you should always test your dApp on a testnet like Rinkeby. Testnets provide a safe environment to experiment with your dApp and identify any potential issues without risking real assets. For example, deploying to Rinkeby. Deploying to Rinkeby involves setting up your Hardhat configuration to specify the network and account details. This allows you to test your dApp in a realistic environment before moving to the mainnet. Verifying contracts. Verifying your smart contracts is essential for transparency. Users can inspect the code to ensure it functions as intended. Platforms like Etherscan provide tools for this process. For example, verifying on Etherscan. To verify your contracts on Etherscan, submit the source code and compiler settings. Etherscan will compare this with the deployed contract on the blockchain, ensuring everything matches. This builds trust with your users. Post-deployment monitoring. Monitoring your dApp after deployment is crucial for maintaining its functionality. Tools like Etherscan, Analytics, and the Graph help you track contract activity and identify any issues. For example, monitoring with the Graph. The Graph allows you to set up subgraphs to monitor specific events, like token transfers. By writing a handler for these events, you can capture and analyze data in real time, providing insights into your dApp's performance. Handling post-deployment issues such as bugs or vulnerabilities is also essential. OpenZeppelin offers a framework for upgrading contracts without disrupting your dApp's functionality. For example, updating contracts. Using OpenZeppelin's proxy pattern, you can deploy new contract versions while keeping the original address. This ensures backward compatibility and smooth upgrades, as shown in the example where a new implementation contract is deployed and the proxy is updated. To wrap up, always rigorously test your dApp before deployment. Use automated scripts to streamline the process and verify your contracts to build user trust. Deploy to a testnet first to ensure a smooth transition to the mainnet. To summarize, today we covered the key steps to deploying advanced apps, from code quality and testing to deployment and post-deployment monitoring. By following these best practices, you can deploy a robust and secure app with confidence. For any further doubts and queries, please reach out to us on our Discord server. Thank you.